Hello, and this is going to be our CS 4800 final project presentation. We are the team debuggers.
I'm Matthew Tam.
I'm Daniel Perez.
I'm Layla Razvi.
I'm Michelle Chang.
I'm Johnny Hawk.
For this class's final project, we have developed a tutoring platform, which is a web application to centralize and categorize tutors at Cal Poly Pomona. Next. Taking a look into our project overview, one of our objectives was efficiency. We wanted to simplify tutor to 2D interactions by streamlining the method of finding and interacting directly with each other. We wanted to provide assistance to students at Cal Poly Pomona who might be struggling to find resources and ensure a way for them to have access to help whenever they need. And lastly, we wanted our tutoring program to help encourage growth for more opportunities for those interested in teaching to start and gain more hands-on experience. Next slide, please. So once again, the significance of our tutoring program or tutoring platform is that we want to help students improve their academic performance, while also giving opportunities for tutors to get experience and learn themselves. With what Cal Poly Pomona currently offers for tutoring, there are a lot of limitations. To list a few of Cal Poly Pomona's resources, there's the LRC, or the Learning Resource Center, the CPP Connect, and the workshops. What we found when we looked through them was that there was a lot of restrictions. Many of these sessions often had set times, which could be inflexible and difficult to be able to fit into different student schedules. The subjects they provided were also very limited in having only specific math classes or maybe a specific English class, or it was too broad in general for tutors and tutees to have a personalized understanding of how to help. There's also no way to find qualifications of the tutors offered, such as which subjects they excel in and their experience level, as tutors which can provide more information for if they are well suited to help assist in specific students' specific academic needs. In addition to all of this, the online platform website providing these services often require a lot of navigation between multiple pages and buttons and links to find what you are looking for. While these tools CPP provides can be helpful, there are additional functionalities that would help support a tutor and tutee's experience. Next slide, please.
So to start off, our initial step was gathering information. So we've conducted several interviews with potential people who would use a platform, which included tutors, which we interviewed in the earlier stages of the project. And these interviews helped us to define the main objective of our project, which is basically to create a centralized platform for tutor and tutee interactions. By understanding their needs, we were able to clearly define the problem, which is the difficulty in finding suitable tutors and scheduling sessions. And overall, from that, we've brainstormed an effective solution. And going on to our next slide, we could talk about the approach. So first, we've researched existing solutions to gain a comprehensive understanding of the problem space. And this allowed us to see what worked well and maybe what didn't work in some other similar platforms that we went off of. Next, we devised a development plan by deciding on the core features that would make our platform stand out. We carefully chose the tools that would best help us achieve our goals. Tools that we're going to talk about in the next slide, but throughout the development process, we constantly checked to make sure that our solution was effectively addressing the problem that we had identified, that we talked about on the last slide. And going on to the next slide, the tools that we've used, we use Figma for designing our user interface and React.js for building the front end. Figma allowed us to create a nice visual representation of our platform, just making it easier to plan and execute our design of what it was going to look like, our platform. React.js was chosen basically for its great use of efficiency and flexibility in building some really great dynamic user interfaces. For the version control, we relied a lot on GitHub or Git and GitHub, and that enabled us to collaborate pretty much well and manage to change our code base as well through that. And finally, we used Firebase for our backend, and that was because of its real-time database capabilities. And it was also really, the integration was working well with React.js, so that was a plus as well. And moving on to the next slide, talking about system requirements. So our platform has several functional requirements to ensure it meets the needs for the users. And the user should be able to search for tutors by subject or course and see feedback from the users. And what this would do is that it would help them make more informed decisions. We also included filters so users can narrow down their choices based on preferences like mode of instruction, availability, or their tutor qualifications. Security was also a good part in designing this, as our website includes robust account creation and management features to keep user information safe. Communication between tutees and tutors was also gone through a built-in system, and tutors can create tutors could create profiles that the tutees can see, and tutees can book sessions through the platform. And lastly, users receive notifications for booking confirmations and session reminders, ensuring that they stay informed about their scheduling sessions. And going on to the next slide.
Okay, so these are the non-functional requirements that are designed to enhance the user experience. So first of all, we have users should not need to navigate more than 3 web pages to begin searching. One of our main motivations for creating the tutoring platform in the first place was to get everything in one place and keep everything simple and coherent compared to the already existing resources. So any more than 3 web pages would just be a puzzle to try to get what you want to do. And then next up, we have website downtime should not exceed 1 hour any day. Downtime is necessary for maintenance and improvements, but it should be kept at a minimum to not cause any inconvenience to users. After that, we have the database should be able to handle a large number of user profiles without performance degradation. And basically, that's what it sounds like on the tin. So if you have a lot of users, then you need to be able to handle having a lot of users. And finally, the interface for the platform should be easy to use for all users, and users should be able to navigate through the platform without any problems. So that means buttons should be clearly noted and they should be visible, and users should be able to tell what each button does. So next slide, please. So for our system design, we split it up into 2 things. First of all, we have the system components, and then second of all, we have the diagrams. Next slide. So we split our components into 3 key components. So first of all, there's the account managing system. Students and tutors are able to create accounts to house information like their own names, their contact information, their preferences, their majors, their qualifications, stuff like that. And everyone will have basic functionalities like logging in, editing their own accounts, viewing other people's accounts, and deleting their own accounts. And of course, students and tutors will have different types of accounts. After that, there's the session booking system, which is made of 2 parts. First of all, there's the search system, where students can search for specific tutors by using a filter for things like subject, the tutor's education, what specific courses, or maybe even the experience or rating of certain tutors. Then through the website, they can book a session with a tutor once a time is agreed upon. And then finally, there's an integrated messaging system. And there's 2 ways students can communicate with tutors. On the account, there's going to be a way to list contact information like a LinkedIn profile, a phone number, and an email, or students can go through the website and directly message the tutor. There's going to be a notification system for the tutor once they receive a message, either via email or phone number. And next slide. So these are system block diagrams. First up, we have the account managing system. And for this, we basically followed the standard create, read, update, delete, where you can create an account. And of course, there's the standard security practices like verifying an account via email and confirming a password. And of course, there's a split between student and tutor accounts. And then you can update your own account. You can view your own profile or other people's profiles. And finally, you can delete an account in case you don't want to have a profile on the site anymore. And after that, there's the booking system, which just going from top to bottom is sort of how it's going to work. So tutors will be able to list their tutoring availability. And then afterward, students can search for specific tutors with an option to filter for specific attributes in their accounts. And then the website's going to return a list of tutors that match their search, where students can then view more specific information on the tutors like reviews and feedback, as well as availability. Students can then book a tutoring session and tutors will be able to confirm, and then both sides will be able to cancel a session for whatever reason. And finally, students can leave reviews and feedback on tutors that they have used. The next slide. And then this is the system block diagram for our chatting system. It's very basic, just one-on-one. Students select a tutor, they can start chatting with the tutor, they can send and view each other's messages, and then finally they can close the chat. Next slide.
So when we were initially designing our system, our sequence diagram consisted of 3 classes, one parent class being the user, and 2 children classes, which are the tutor and tutee. Now, the user class, as depicted in the user sequence diagram, has a user viewing the sign-in page when attempting to make an account or log in. After viewing this page, they can either select register or log in. Now, if they select log in, the user controller checks to see if the user's data exists within the database, and if it does, it would retrieve it using the get user info method and load the user's data into the current instance of the website. Then it would call the return user info method and redirect the user to the home page if it was successful. If their account does not exist, it will alert them that their account simply doesn't exist. Now, if the user selects register, it would prompt them to fill out a form that they need to select, where they would need to select either a tutee or tutor and fill out the respective information. This will be visualized in the following sequence diagrams. Next slide, please. Now, this sequence diagram represents the sequence of events if a user has registered or logged in as a tutor. The tutor would be able to interact with a profile page that allows them to update their information and view feedback given to them. The tutor would also be able to select an account page that allows them to update it using the update availability method, which will send the changes to the database by calling the update profile method. This would then return and update the tutor's new availability and data to be consistent with the database and the website. Now, the tutor would also be able to view any ratings they've received from previous tutees directly from the profile page. Now, this page will send an integer, which represents the tutor's ID number, to retrieve feedback directed to that tutor and open a page for them to view it. Now, this ID system is simply meant to simplify the tutor to tutee interaction within code by only needing to retrieve one value. Next slide, please. Now, the tutee would also have similar methods to update their availability and information as a tutor, so representing it here again would actually just be redundant. Instead, this diagram represents how a tutee would be able to search for tutors. Now, tutees are able to search, will be able to open a search page and search for tutors via specifying certain criteria. And the search page would search the database and fulfill these criteria with these specifics and retrieve these tutors via their tutor ID. Now, viewing the tutor's ratings would also follow a similar process. And if the tutee wanted to schedule a session with the tutor, they would be able to via exchanging tutor ID and tutee IDs to start chatting with the respective user. Next slide, please. Now, our plan was to have 5 classes in total. As specified before, the user would be a parent class to the tutor and tutee. And after reducing the scope of our project, we narrowed it down to just 3 classes. However, if the chat and feedback features were fully implemented, tutor and tutee would be able to interact with the chat and feedback classes. Now, the chat class would only have the start chat method accessible to the tutees. And once the tutee has initialized the instance of the chat, the tutor would also be able to access the chat with the potential 2D and send messages. Now, users would also be able to view all users would be able to view the feedback on each tutor, but only tutees with previous instances with the tutor would actually be able to call the add feedback method and leave a review. All the users will only be able to review it. Next slide, please.
As for system testing, we mainly had to focus on development testing as we didn't have time for validation testing or sharing results with our potential stakeholders. We tested the core features of our project that we could implement. As for the features that were successful, we were able to implement page routing, user account creation and sign up and login. Users can identify whether they're a tutor or tutee. The user interface was working as expected, as well as the search bar, searching tutors effectively, and the database was able to handle multiple users. We weren't able to implement account management as well as filters for searching the tutors, which would include filters by subject or by course. We also weren't able to implement the tutor feedback feature and the booking sessions with tutors. For what we were unsure about was the security of Firebase for user accounts, which was unknown to us. As for challenges and solutions, our main challenge was the limited amount of time we had to implement the project, as well as some of our inexperience with the tools. To handle this, we used the cost value approach to determine the most critical features to implement. Another challenge we had was using the Git version control and having merge issues with different branches. So how we handled with this was to modularize the code and assign team members to different parts of the project to minimize conflicts. And then in general, we at the beginning had issues with some communication, determining the scope of the project, and one of the biggest features was the account creation system. But as we got into the workflow and began communicating with each other consistently, we were able to decrease the challenges and difficulties with our work process. And in conclusion, we were able to implement our core features for the project and achieve our project goal of creating a platform for Cal Poly Pomona students to find tutors. And through this, we were able to practice web development and team collaboration, along with software engineering principles. If we were to expand on this project in the future, we would like to complete the implementation of the booking system and improve the search filtering and capabilities, as well as the in-app direct messaging system. And that concludes our presentation. Thank you so much.